Okay, in these next two examples in 3.4, we're going to talk about rate, but graphically. So we're going to use a rate to hopefully draw a linear graph, a graph of a line. Or if I give you the graph of a line, could you figure out what the rate is of this graph? All right, let's look at example number 3. It says draw a linear graph to represent the given information. Between 2004 and 2010, the additional yearly amount of Brazilian rainforest that was deforested decreased by 1,250 square miles per year. Ooh, did you just hear that? It looks like we have a rate here, square miles per year. So I can actually write that as a ratio, if you wanted to, of 1,250 square miles per 1 year. So that kind of helps us give us a rate. How fast or slow is this rainforest growing or decreasing? It says here during 2004, approximately 10,000 square miles of rainforest was deforested. So that's an additional piece of information that we might need to use. So when we're looking at this, we want to make sure that we do a couple different things as we're graphing. The first thing we want to do is make sure that we label. We label our x-axis properly and our y-axis properly. When we're talking about graphs, we often need to think about what is our independent variable and what is our dependent variable. What is our independent variable would be our x, and our dependent variable would be our y. A lot of times when we're talking about time, our time, minutes, hours, years, is going to be our independent variable. That's one thing that we can't necessarily control. But as time goes on, we can figure out what output we're going to have. That's our dependent variable, or our y. So in this case, our years are going to be our independent variable, our x-axis, and our forest that has been deforested, our square miles, is going to be our dependent variable. So depending on what the year is, will depend on how much rainforest has been deforested. So that's going to be along our y-axis. Now let's go ahead and put a scale on our graph. We need to figure out what we're going to label our x-axis, what increments we're going to go up or down by, and what we're going to label our y-axis, what we're going to go up and down by. Well, if you notice in our problem, the years started at 2004 and ended at 2010. So we want to make sure that we at least get all of those years down. So looking at my x-axis, I kind of broke it up like this. I gave a little bit of space so everything wasn't crammed together. I put 2004, then 2006, then 2008, then 2010. So it looks like here would be 2005, 2007, 2009. So I've kind of spread it out. You can spread yours out even more if you want to, condense it if you want to, but just kind of making sure that we use as much of our graph as possible and everything's not too squished or too wide. The next thing we want to do is label our y-axis. Now remember, our y-axis is going to be the square mileage. And it says here there is a rate of 1,250 square miles per year. And it also says in 2004 that there were 10,000 square miles. Now we need to at least have 10,000 on our graph. And then we also have to think, is our rate going to go up or is it going to go down? Well, if you notice, one of the big key words here is that the rainforest deforesting decreased, meaning it went down. So in 2004, if it started at 10,000, it should go down from there. So our highest Y value needs to be 10,000. So we need to make sure that we at least fit up to 10,000 on there. Okay, so let's think about how we're going to organize our Y-axis. We don't want to go up 1, 2, 3, 4, 5, because then we would run out if we wanted to get all the way to 10,000. So this is what I started with. I started with, I don't know, maybe 1,000. Then I went 2,000, 3,000, 4,000, 5,000. So every single unit is up by 1,000. And that hit me all the way to 10,000, making sure that I was still on my graph. So that worked perfectly. And you can put all of the different ones in here. I just didn't want to put too much and get too squished in here, but every single one of these units is worth 1,000 square miles. Okay, the next thing we need to do is graph. Graph using the information. We know a starting point. We know in 2004 that 10,000 square miles of forest was deforested. We know where 2004 is. We can follow it up to 10,000, and we can plot a point here, an ordered pair. So in 2004, we can say that approximately 10,000 square miles of rainforest was cut down. Okay, then it says there are 1,250 square miles per every year after that that was decreased. So we can take this original information of the 10,000, we can go down, right, 1,250 square miles per year over to the right. So let's kind of use that. We want to go down by 1,250. So now we need to be careful. If I go down from 10,000 to 9,000, that's 1,000. But I want to go down a little bit more than that to 1,250. So maybe about right there. Per every 1 year. So I need to go over 1 year to 2005. So there's my next value. So now I have something that kind of looks like this. Whoop. And I can do it again. If this is going to continue, this rate is going to continue every single year, we can go down by 1,250 square miles per year every single year and kind of graph that same rate to kind of show the linear relationship between the two values. We can then use it, maybe, to estimate how much rainforest is going to be cut down in 2011 or 2012 or something like that. But using this rate to help us determine what our line is going to look like. Okay, what if I already gave you a line though, and I asked you to figure out what the rate was? For example, in example number 4, it says Nadia prepared the following graph from the data collected on a recent day at a branch bank. So she works at a bank and she collected some information. It looks like on the x-axis, it's the time of day. So she started at 9, 10, 11, noon, 1 o'clock. So it looks like they're going up by hours, right? So these are hours. On the y-axis, it looks like she has number of transactions. So how many transactions she took care of during the day, 50, 100, 150, 200, and so on. It looks like at 9 o'clock, she made how many transactions? Well, between 50 and 100, it looks like 75, right? So we have this piece of information symbolized by that ordered pair. We also have another piece of information symbolized by this ordered pair. It looks like at 11 o'clock, she had already made 225, right? Transactions. So we want to figure out what her rate is. We want to figure out how many transactions she made over this span of time. Do you notice how I went up and over? I went up and to the right. And so what we're looking at is how many transactions she made per hour. So that would be my rate, transactions per hour. And that's what example number 4a is asking. What rate can be determined from the graph? It looks like the number of transactions per hour. Okay, so now let's actually find the rate. So how many transactions did she make over that period of time? Well, she started at 75 and went up to 225. We can figure out how many transactions that is by subtracting them, right? Per hour. Well, if she started at 9 and then we have another ordered pair at 11, how many hours is that? Well, it looks like from 9 to 11 is 2 hours. Whoops, where did we go here? Okay, so it looks like she made 150 transactions in 2 hours. If we want to have a unit rate, we want to divide that and say that really she made 75 transactions per hour. So that was the rate at which she worked. On average, she made about 75 transactions per hour. We can use the graph, find 2 points, ordered pairs on the graph, and figure out what the change was in the y-axis versus the x-axis, the rate of change.